Right now, we know of over 100 planets outside our solar system going around other stars. And the amazing thing is that none of the planets we've found so far are anything like Earth.
The search for extrasolar planets, or planets outside our solar system, is a relatively new field. Ultimately, the techniques we are developing now should lay the groundwork for detecting life on other planets.
In the past, we've mainly made telescopes that see the universe like our eyes do. They use visible light. But it turns out that that's just a tiny, tiny little range of the light that exists. And a lot of the really important questions about how stars form and how planets form, the answers to those lie in the infrared. SIRTF stands for the Space Infrared Telescope Facility, and it's NASA's newest great observatory. We're a lot like the Hubble Space Telescope, but instead of seeing visible light, we look completely in infrared light, which you normally think of as heat light. Infrared light is really a direct measurement of temperature. Our eyes are not sensitive to any kind of infrared light. But with the help of a computer and some detectors, we can turn it into images that our eyes can understand. One of SIRTF's main objectives is to understand how stars and planets form. For a long time, this information has been hidden from us because stars and planets form inside giant clouds of interstellar dust that completely block out any visible light. The dust does give off heat, though. And that's the whole point with having a heat-sensitive telescope. The amazing thing about this dust is that the chemistry in it is very similar to the chemistry of life that we find here on Earth. We find water, amino acids, molecules floating around between the stars. That's all present in the dust. So when we try to answer that question, where did we come from, the dust is very important. The dust holds the secrets to how stars form, how planets form, and even how life forms out of that chemistry. Not only are we going to be able to look inside dust clouds and see stars forming, but we can watch planets form out of the disks of dust that form around young stars. Right now, we know of about 100 planets outside the Earth. We really only know of a small number of planetary systems. But one of the things that I'm really hoping for is that after a couple years of SIRTF being up there, we will perhaps know of hundreds or maybe even thousands of stars that have the warm dust that forms planets around them.
While SIRTF is looking for stars with orbiting disks of warm dust, the precursors of planetary systems, we're actually attempting to see the planets themselves. To date, nobody has ever taken a picture of an extrasolar planet. It's a challenge primarily because the stars themselves are so bright that they drown out any hope of seeing those planets themselves. Well, not any hope. Actually, we have hope, and it comes from trying to manipulate the star's light, essentially trying to get rid of as much of it as possible so that we can see the planet. I'm currently leading the Lyot Project at the American Museum of Natural History. Bernard Lyot invented coronography in the 1920s, essentially to make pictures of the sun's corona. The corona is this gas emanating from the sun, and it's about 1 million times fainter than the disk of the sun itself. We're using the same technique, but on distant stars, not to image their coronas, but to look at faint objects orbiting these stars, possibly even Earth-like planets. We're building the Coronagraph at the American Museum of Natural History. And what we essentially have to do is get the whole system fully operational here in New York, and then ship it out to the US Air Force Telescope in Maui. Test the alignment out there, incorporate it with the camera, and start pointing the telescope at nearby stars. This is the 3.6 meter AOS telescope operated by the US Air Force. It's on top of Mount Haleakala in Maui at about 10,000 feet. And we're using it as guests funded by the National Science Foundation and the US Air Force in order to try to image planets orbiting other suns. Light from the telescope comes through that port there, reflects off this mirror here, hits the large parabolic mirror there, which starts to bring light into a focus, and then it gets relayed along these mirrors into this infrared camera here and a visible light camera there. This camera itself is the same one we'll be using with the Coronagraph when we bring it out in October, and it will sit roughly where it is now. The Coronagraph itself will sit about here, and it will be an enclosed steel case. The Lyot Project Coronagraph will be used to survey approximately 300 nearby stars to look for anything faint orbiting those stars. If you can actually see the planets that you're trying to study, you can learn much more about them. For example, you can study the colors that they emit, the spectra of their atmospheres. You can determine the chemical compositions of their atmospheres. You can determine physical characteristics of their atmospheres and even their surfaces. And ultimately, you can use these measurements to look for signs of life on these planets.
I think most scientists agree that there really have to be Earth-like planets out there. The problem is we just don't have the technology yet to find them, but we're right on the cusp. I really do think that in our lifetime, in the next 50 years, we're going to find a planet the same mass as the Earth and maybe with the same chemistry as the Earth.